Hi everyone, welcome to the Cosmic Space Channel. Tonight, we'll journey through the deepest mysteries of the universe. If you're ready, let's begin. You slowly leave the present behind. The world you know begins to fade away. Cities, oceans, mountains. Everything disappears into the distance. Your journey carries you farther back than any human has ever traveled. Not thousands of years, not millions, but billions. Long before Earth existed. Long before the sun illuminated the planets. Long before life took its very first breath. Around 4.6 billion years ago, our solar system was nothing more than an immense cloud of gas and dust drifting through the Milky Way. It was quiet, cold, and almost perfectly still. Earth had not yet formed. Nothing here resembled the peaceful blue world we know today. The space around the young sun was filled with countless fragments of rock, metal, and frozen material. Every object followed its own orbit. Some collided gently. Others struck with unimaginable force. Each collision released enormous amounts of heat. Every impact helped shape the future of the solar system. Among those countless fragments, one body slowly began to stand out. Gravity pulled more and more material toward it. With every collision, it became larger. With every passing million years, its gravity grew stronger. This young world was the early Earth. Its surface looked nothing like it does today. There were no oceans, no continents, no atmosphere capable of supporting life. The entire planet was covered by a global ocean of molten rock. Volcanoes erupted across the surface without interruption. Rivers of lava stretched for hundreds of kilometers. The sky glowed with ash, dust, and volcanic gases. Temperatures remained high enough to melt nearly every rock that reached the surface. Deep inside the planet, something remarkable was happening. The heaviest elements, such as iron and nickel, slowly sank toward the center. Lighter rocks floated above them. This process separated Earth's interior into distinct layers. A dense metallic core formed at the center. Above it, the mantle continued to flow like an extremely thick liquid. Slowly, the structure of our planet began to take shape. The violence, however, was far from over. Roughly 4.5 billion years ago, another young world crossed Earth's path. Scientists call this ancient planet Theia. It was approximately the size of Mars. The collision changed everything. The impact released more energy than billions of nuclear explosions combined. Part of Earth's outer layers was blasted into space. Much of Theia was destroyed as well. For a short time, our planet was surrounded by an enormous ring of glowing debris. Rock, metal, molten fragments, all orbiting Earth. Gravity slowly gathered those fragments together. Over time, countless smaller pieces merged into one larger body. That body became the Moon. It did not appear overnight. Its formation likely took thousands of years. As the Moon grew, it slowly moved farther away from Earth. Its gravity began influencing our young planet. The tides became stronger. Earth's rotation gradually slowed. The chaotic young world was beginning to find balance. Yet life was still impossible. The greatest changes were only beginning. The moon continued drifting away from Earth. Not by kilometers each day, but by only a few centimeters every year. Even today, that slow journey continues. Its gravity steadily pulled on Earth's oceans. Powerful tides swept across the planet. They reshaped the coastline of a world that still had no continents. At the same time, Earth's interior remained incredibly hot. Heat trapped beneath the crust searched for a way to escape. Volcanoes erupted across the surface without pause. Each eruption released enormous amounts of water vapor, carbon dioxide, nitrogen, and other gases. There was still no breathable air. The atmosphere was thick, dark, and toxic. If you could stand on Earth's surface at that time, you would see nothing but lava fields stretching to the horizon. The sky would glow orange through dense volcanic clouds. The air itself would be impossible to breathe. As millions of years passed, the planet slowly began to cool. The surface hardened. The first solid crust appeared. It was fragile, thin, and constantly broken apart by impacts from space. Asteroids and comets still struck Earth on a regular basis. Each collision released tremendous energy. Some impacts melted entire regions of the young crust. Others delivered something that would eventually change the planet forever. Water. Many scientists believe that a significant amount of Earth's water arrived aboard icy asteroids and comets. Others believe part of it had already been trapped inside the planet since its formation. Most likely, both processes played an important role. As the surface continued cooling, the thick clouds of water vapor finally began to condense. For the first time in Earth's history, rain began to fall. Not for hours, not for days, but for thousands of years. The rain fell onto hot volcanic rock. It instantly turned back into steam. Again and again, the cycle repeated. Eventually, the surface became cool enough for the water to remain. The first oceans slowly appeared. They covered much of the young planet. Earth was finally beginning to resemble the blue world we know today. But beneath those quiet oceans, an entirely different story was about to begin. One that would eventually lead to every plant, every animal, and every human being that would ever live. The oceans covered most of the planet. From space, Earth finally began to shine with deep shades of blue. But beneath those calm waters, the planet remained restless. Its core was still thousands of degrees hot. Powerful currents moved slowly through the mantle. The solid crust above could not remain in one piece. It cracked, shifted, and drifted across the surface. The first tectonic plates were born. Volcanoes rose from the ocean floor. New crust formed as molten rock reached the surface. Older crust slowly disappeared beneath younger plates. Earth had become a world in constant motion. This movement continues even today. Every mountain range, Every ocean basin, every continent owes its existence to this slow process. The atmosphere also continued to change. Volcanic eruptions filled the sky with carbon dioxide, water vapor, sulfur compounds, and nitrogen. Sunlight struggled to reach the surface. The young sun was slightly dimmer than it is today. As a result, the planet entered long periods of extreme cold. Ice spread across vast regions of the globe. Some scientists believe that, at certain times, nearly the entire planet was covered in ice. Even the oceans may have frozen over. From space, Earth would have appeared as a brilliant white sphere. Yet beneath that frozen surface, the planet never stopped working. Volcanoes continued erupting beneath the ice. They released carbon dioxide into the atmosphere for millions of years. Slowly, the greenhouse effect became stronger. Temperatures began to rise. The ice melted. Rivers returned. The oceans became liquid once again. Earth had survived another chapter of its violent history. Every cycle of fire and ice transformed the planet a little more. The world was becoming increasingly stable. Conditions were improving. For the first time, nature was preparing a place where life might one day emerge. No one witnessed those ancient moments. No human eyes were there to see them. Yet every rock beneath our feet still carries the memory of that distant past. The story of life was about to begin. Life did not appear in an instant. It was the result of hundreds of millions of years of change. The oceans had become more stable. Volcanic activity continued beneath the surface. Minerals flowed into the water. Energy from Earth's interior mixed with the chemistry of the ancient seas. Somewhere in those vast oceans, the first simple molecules began interacting in new ways. Over immense periods of time, those interactions became more complex. Eventually, the first microscopic life appeared. It was incredibly simple, invisible to the human eye. Yet it marked one of the greatest moments in the history of our planet. For billions of years, these tiny organisms were the only living inhabitants of Earth. They covered the oceans long before the first fish appeared. Long before forests. Long before dinosaurs. Long before humanity. Many of these early organisms used sunlight as a source of energy. As they spread across the oceans, they slowly released oxygen into the atmosphere. At first, that oxygen did not remain in the air. It reacted with iron dissolved in the oceans. Layer after layer of iron oxide settled onto the seafloor. Even today, those ancient rocks preserve evidence of this remarkable transformation. Eventually, the oceans could no longer absorb all the oxygen being produced. The atmosphere itself began to change. The amount of oxygen slowly increased. It was one of the most important turning points in Earth's history. An atmosphere rich in oxygen made complex life possible. Without it, animals and humans could never have existed. Millions of years became billions. The continents slowly drifted across the planet. Mountains rose. Others were worn away by wind and rain. Oceans opened and closed. Entire landscapes disappeared before new ones took their place. Earth never stopped changing. It still has not. Every earthquake, every volcanic eruption, every movement of the continents reminds us that our planet is alive. The ground beneath our feet may seem permanent, but on the scale of geological time, it is constantly moving. The Earth we know today is only a single moment in a story that has lasted for more than 4.5 billion years. And that extraordinary journey is still unfolding. For billions of years, Earth continued to change. The continents never remained in one place. They drifted across the planet at the speed that fingernails grow. Slow enough to go unnoticed in a single lifetime. Powerful enough to reshape the entire world. At times, nearly every continent joined together to form one enormous landmass. Scientists call it Pangaea. From coast to coast, it stretched across a large part of the planet. But even that giant continent did not last forever. Deep beneath the surface, Earth's mantle continued to move. The crust slowly fractured. The continents separated. New oceans opened between them. The familiar shapes we recognize today slowly emerged. Africa moved away from South America. India began its long journey north. Millions of years later, it collided with Asia. The impact pushed the land upward. The Himalayas began to rise. Even today, those mountains continue growing a little higher each year. While the continents moved, life continued to evolve. Simple organisms gave rise to increasingly complex forms. The oceans filled with strange creatures. Fish appeared long before animals ever walked on land. Eventually, plants spread across the continents. Forests covered vast regions of the planet. The atmosphere became richer in oxygen. Life flourished in ways that had once seemed impossible. Then came the age of giants. Dinosaurs ruled Earth for more than 160 million years. They lived through changing climates, shifting continents, and countless generations. For a time, they were the dominant form of life on the planet. But Earth's story has never followed a straight path. Around 66 million years ago, another visitor arrived from space. A massive asteroid entered Earth's atmosphere at incredible speed. The impact released an unimaginable amount of energy. Wildfires spread across entire continents. Dust filled the atmosphere. Sunlight was blocked for months, perhaps even years. Global temperatures dropped. Many species disappeared, including the dinosaurs. Yet life did not end. It adapted, recovered, and slowly began another chapter. Every ending on Earth has also been the beginning of something new. The planet has always found a way to move forward. Its story is written not only in stone, but in every living thing that exists today. Humanity arrived only moments ago in Earth's immense history. If the entire age of our planet were compressed into a single day, humans would appear only in the final seconds before midnight. Everything that came before prepared the world we now call home. The mountains beneath our feet, the oceans that surround the continents, the air filling every breath. Each of them is the result of billions of years of change. Even today, Earth has not reached the end of its journey. The continents continue to drift. New mountains slowly rise. Old mountains gradually disappear. Earthquakes remind us that the crust is always moving. Volcanoes release heat from deep within the planet. Far below the surface, the core continues its endless motion. That movement creates Earth's magnetic field, an invisible shield that protects our world from the constant stream of charged particles flowing from the Sun. Without it, life on the surface would face a far harsher environment. Our atmosphere also plays a remarkable role. It keeps our planet warm enough for liquid water. It burns up countless meteoroids before they reach the ground. It allows clouds to form, rain to fall, and life to thrive. Everything works together in a delicate balance. A balance shaped over billions of years. When we look at Earth from space, it seems calm, peaceful, almost timeless. Yet beneath that quiet appearance lies a planet that has never stopped changing. The world we know today will not remain the same forever. Millions of years from now, the continents will once again take on new shapes. New oceans will form. Others will disappear. Mountain ranges will rise where flat plains exist today. The map of Earth will be completely different. Even farther into the future, the Sun itself will continue to change. As it ages, it will slowly become brighter. The increasing heat will gradually transform Earth's climate. The oceans will eventually begin to disappear. Long before the Sun reaches the final stages of its life, our planet will become a very different place. Nothing in the universe remains unchanged forever. Not stars. Not planets. Not galaxies. Change is the quiet rhythm of the cosmos. And Earth has followed that rhythm since the day it was born. Today, we are only one small part of its extraordinary story. A story that began billions of years before us, and one that will continue long after we are gone. The story of Earth is also the story of time. Every cliff, every valley, every grain of sand has been shaped by countless years of change. Rocks preserve the memory of ancient oceans. Mountain peaks reveal the immense forces that lifted them toward the sky. Deep beneath the surface, minerals formed under pressures impossible to imagine. Together, they record a history far older than humanity itself. Scientists have spent generations studying these silent records. Meteorites have revealed clues about the birth of the solar system. Ancient crystals have preserved evidence from Earth's earliest days. Fossils have captured moments from worlds that vanished millions of years ago. Each discovery has added another piece to an extraordinary puzzle. Today, we estimate Earth's age to be about 4.54 billion years. That number was not guessed. It was measured through careful analysis of ancient rocks and meteorites. Although our planet constantly renews its surface, some of the oldest minerals still survive. They remind us how incredibly ancient our home truly is. Earth is not a perfect sphere. Its rotation causes the equator to bulge slightly outward, As a result, the distance across the equator is greater than the distance from pole to pole. The difference is only a few dozen kilometers. Small compared with the size of the planet, yet large enough to measure with remarkable precision. Only a small portion of Earth is directly accessible. We can explore the oceans, climb the highest mountains, drill a few kilometers into the crust. But the deepest parts of our planet remain beyond our reach. Everything we know about the mantle and the core comes from careful observation. When earthquakes occur, they send waves through the planet. Those waves travel at different speeds through different materials. By measuring them, scientists can build a picture of Earth's hidden interior. It is like listening to an unseen world instead of looking at it. Those invisible signals have revealed a layered planet, a thin crust, a vast mantle, a liquid outer core, and a solid inner core composed mostly of iron and nickel. Together, these layers have worked in harmony for billions of years. They continue shaping the world beneath our feet. Even now, while life goes on above the surface, Earth is quietly changing below us. Its story never truly pauses. It simply unfolds one moment at a time. Our planet has existed for more than 4.5 billion years. Yet human civilization occupies only the smallest fraction of that history. Every city, every road, every monument, every generation. Together they represent only a brief moment on the geological timeline. Earth has witnessed events far greater than anything recorded in human history. Entire mountain ranges have risen and disappeared. Oceans have opened and closed. Countless species have appeared, flourished, and vanished. Still, the planet continued its journey. When we look up at the night sky, it is easy to feel that Earth is standing still. In reality, nothing is motionless. Earth rotates once every 24 hours. At the same time, it travels around the Sun at nearly 30 kilometers every second. The solar system itself orbits the center of the Milky Way. Even our galaxy moves through the universe. We are passengers on a world that has never stopped moving. And yet, from our perspective, everything feels calm. That quiet stability is one of Earth's greatest gifts. It allows rivers to carve valleys over millions of years. It allows forests to grow. It allows life to evolve. It allows civilizations to exist. Every sunrise reminds us that Earth is turning. Every season reminds us that it is orbiting the Sun. Every star overhead reminds us that our world is only one small part of a much greater universe. Perhaps that is what makes Earth so remarkable. Not because it is the largest planet, not because it is the oldest, but because, as far as we know, it is the only world where oceans, mountains, clouds, forests, and life have come together in perfect balance. Everything around us is connected. The oceans shape the climate. The atmosphere protects the surface. The moon stabilizes Earth's rotation. The magnetic field shields the planet from harmful radiation. Remove just one of these pieces, and Earth would become a very different place. After billions of years of change, countless coincidences, and extraordinary natural processes, our planet became a place where life could flourish. That fragile balance continues today. And every new day becomes another page in the endless story of Earth. Take one final look at our planet. From this distance, there are no borders, no cities, no roads. Only a small blue world floating through the darkness of space. The oceans reflect the light of the sun. White clouds drift slowly across the continents. Above them, a thin layer of atmosphere protects every living thing below. It is surprisingly fragile. If Earth's atmosphere were reduced to the size of a globe, the breathable layer would be thinner than the skin of an apple. Yet that delicate layer makes every breath possible. Below it, forests quietly produce oxygen. Oceans regulate the climate. Rivers carry fresh water across the land. Every part of the planet supports another. Nature is built upon countless connections. Most of them are invisible until they are disturbed. Earth has survived asteroid impacts, global ice ages, powerful volcanic eruptions, mass extinctions. It has endured events that reshaped the entire planet. And after each one, life slowly returned. Sometimes in a different form. Sometimes more diverse than before. Resilience has always been part of Earth's story. That resilience, however, should never be mistaken for permanence. The balance that supports life is remarkably delicate. Small changes can echo across the entire planet. The choices made by one generation can influence many that follow. Perhaps the greatest lesson hidden within Earth's history is patience. Nothing important happened overnight. Mountains required millions of years to rise. Oceans required millions of years to form. Life itself required billions of years to reach the richness we see today. Every chapter was built upon the one before it. Every moment prepared the next. Tonight, as you rest beneath the same sky that has watched over Earth for billions of years, remember how extraordinary this journey has been. From a cloud of dust drifting through the galaxy, to a world filled with oceans, forests, and life. It is a story written across billions of years. And tonight, for a brief moment, you have traveled through it. As our journey through Earth's history comes to an end, one thought becomes impossible to ignore. Everything around us is the result of time. The ground beneath your feet, the water flowing through rivers, the mountains standing against the horizon. Even the air filling your lungs has been shaped by processes that began billions of years ago. Nothing appeared by chance in a single moment. Earth became what it is through patience. Every impact, every eruption, every frozen age, every quiet period between them added another layer to its story. The planet we know today is the product of countless transformations. It continues to change with every passing day. The continents still drift across the surface. The oceans still reshape the coastlines. The atmosphere continues protecting life from the harsh environment of space. Far below us, the core continues generating the magnetic field that surrounds the planet like an invisible shield. Even while we sleep, Earth remains active. Its story never pauses. It simply moves too slowly for us to notice. Perhaps that is why geology teaches us humility. Human lives feel long to us. Civilizations may seem permanent. Yet on Earth's timeline, they are only brief moments. The rocks beneath our feet have witnessed worlds that existed long before humanity. They will remain long after today's cities have disappeared. When we look into the night sky, we often search for distant planets. We wonder whether another world like Earth exists. Perhaps somewhere among the hundreds of billions of stars in our galaxy, another blue planet is quietly orbiting its own sun. Perhaps oceans cover its surface. Perhaps clouds drift through its skies. Perhaps life has also found a way to begin. For now, we simply do not know. Until that answer arrives, Earth remains the only home we have ever known. A small world orbiting an ordinary star. Yet extraordinary in every way that truly matters. Thank you for taking this journey across billions of years. As you close your eyes tonight, remember that you are resting on a planet with a story older than imagination itself. A story that is still being written. One quiet day at a time. Beyond our world, the universe stretches farther than the human mind can truly imagine. Our solar system is only one among billions. The Milky Way alone contains hundreds of billions of stars. Many of those stars are surrounded by planets. Some are rocky worlds like Earth. Others are giant planets larger than Jupiter. Astronomers have already confirmed thousands of these distant worlds. With every new discovery, one question returns. Could another planet also support life? The answer remains unknown. What we do know is that Earth possesses an extraordinary combination of conditions. The right distance from the Sun, liquid water on the surface, a stable atmosphere, a protective magnetic field, an active interior that constantly renews the planet, and a large moon that helps stabilize Earth's rotation. Each of these factors plays an important role. Together, they created a world where life could survive and evolve. Perhaps similar worlds exist elsewhere. Perhaps they are waiting to be discovered. Future generations may one day answer that question. For now, our own planet remains the greatest example we have of how remarkable the universe can be. The story of Earth also reminds us of something else. The atoms within your body did not begin here. The carbon in your cells, the oxygen you breathe, the iron in your blood. All of these elements were forged inside ancient stars long before the Sun was born. When those stars reached the end of their lives, they scattered their elements across space. From that cosmic material, new stars formed. New planets appeared. Eventually, one of those planets became Earth. In a very real sense, every living creature carries the history of the universe within itself. We are connected not only to this planet, but also to the stars that existed billions of years before it. The journey that began inside a distant cloud of gas and dust eventually became oceans, mountains, forests, and life. It became every sunrise, every wave reaching the shore, every forest moving with the wind. Every person who has ever looked up at the night sky and wondered where it all began. That question continues to inspire us today. And perhaps it always will. Every night, the sky reminds us of where we came from. The stars above may seem silent, yet each one tells a story that began long before Earth existed. Some are only a few million years old. Others have been shining for billions of years. Many have already reached the end of their lives. Their light is only now arriving at our planet. When you look into the night sky, you are also looking into the past. The farther away a star is, the longer its light has traveled. Some of the faint points above us began their journey before the first humans walked the Earth. Others started long before the dinosaurs. A few have traveled for millions of years just to reach your eyes tonight. Space is not only unimaginably vast, it is also a record of time itself. Every direction you look reveals another chapter of cosmic history. Our own sun is one of those countless stars. It is neither the largest nor the brightest. It is an ordinary yellow dwarf. Yet for Earth, it is everything. Every sunrise carries energy that began deep inside the sun's core. There, hydrogen atoms merge together under tremendous pressure. That process releases light and heat. The energy then begins an incredibly long journey toward the surface. A single particle of light can spend thousands of years moving through the sun before finally escaping into space. Once it leaves the surface, it reaches Earth in just over 8 minutes. Those same rays warm the oceans, power the winds, feed forests, and make life possible. Without the sun, Earth would become a frozen world drifting through darkness. Every heartbeat, every tree, every drop of rain depends on the steady light of a single ordinary star. Perhaps that is one of the universe's greatest lessons. Even something that appears ordinary from a distance can become extraordinary to those who depend on it. And for us, there has never been a more extraordinary star than the one we simply call the sun. The next time you look at the night sky, remember that every point of light has its own story. Some stars are just beginning their lives. Others are approaching their final chapter. Some planets are only now taking shape inside distant clouds of gas and dust. Elsewhere, new solar systems may be forming at this very moment. The universe never stands still. Creation and change continue everywhere. Our own planet is part of that endless cycle. Earth was born from the remains of older stars. One day, the atoms that make up our world will become part of something new. Nothing is truly lost. Everything is transformed. That simple idea connects every star, every planet, and every living creature. It connects the distant past with the present. And it connects us with a universe far larger than we can ever fully explore. Tonight, as the world grows quiet, there is no need to rush. The story of Earth unfolded over billions of years. The universe is in no hurry. The stars will continue shining. The planets will continue their silent journeys. The moon will continue circling Earth, just as it has for billions of years. and our small blue world will continue traveling around the Sun, carrying every ocean, every mountain, and every living creature with it. For now, simply enjoy the quiet. Let your thoughts become lighter. Let the silence of space surround you. And let the remarkable story of our planet slowly drift into the background as you rest. You continue your peaceful journey through the solar system. The farther you travel from the Sun, the darker space becomes. The warm light that once filled the inner planets now feels distant. Ahead, a faint point of light slowly begins to grow. At first, it looks like an ordinary star. But with every passing moment, its true size becomes impossible to ignore. A giant is waiting in the darkness. Jupiter, the largest planet in our solar system. A world so immense that more than 1,300 Earths could fit inside it. Yet despite its incredible size, it is not a rocky planet. There is no solid surface waiting beneath the clouds. No mountains. No oceans. No place where you could ever stand. Jupiter is a giant world made almost entirely of hydrogen and helium, the same elements that formed the Sun. As you move closer, the planet fills more and more of the sky. Bands of white, orange, brown, and cream stretch around the entire globe. Each band marks powerful winds flowing in opposite directions. Some of these jet streams race through the atmosphere at hundreds of kilometers per hour. Far below those colorful clouds, the pressure increases beyond anything we experience on Earth. The deeper you descend, the more extraordinary Jupiter becomes. The gas is compressed so intensely that hydrogen begins behaving like a liquid metal. This strange layer is believed to generate the most powerful magnetic field of any planet in the solar system. That invisible shield stretches millions of kilometers into space. It traps enormous amounts of energetic particles. Radiation near Jupiter becomes so intense that it would be extremely dangerous for both spacecraft and humans. Despite its violent nature, Jupiter has quietly protected the inner solar system for billions of years. Its immense gravity captures or deflects countless comets and asteroids. Many scientists believe that this giant planet has reduced the number of catastrophic impacts that might otherwise have reached Earth. In a way, Jupiter has acted as a distant guardian throughout much of our planet's history. From here, its immense size is almost impossible to comprehend. The clouds never stop moving. Storms appear and disappear across the atmosphere. The entire planet completes one rotation in less than 10 hours. It is the fastest spinning planet in the solar system. That rapid rotation gives Jupiter its slightly flattened shape, making it wider around the equator than at the poles. Every moment spent near this giant world reminds you that planets come in many different forms. Some are quiet. Some are frozen. Some are covered with oceans. And some, like Jupiter, are restless giants that have never known silence. As you continue drifting closer, one feature immediately captures your attention. A storm unlike anything found anywhere else in the solar system. The Great Red Spot. The Great Red Spot has been raging for centuries. It is the largest and most famous storm in the solar system. For more than 350 years, astronomers have watched it swirl across Jupiter's atmosphere. Even today, it refuses to disappear. From a distance, it resembles a giant crimson eye staring into the darkness of space. Its colors shift between deep red, orange, and pale salmon tones. No one knows exactly what gives the storm its distinctive color. Scientists continue searching for the answer. The storm rotates slowly in a counterclockwise direction. Powerful winds race around its edges at speeds exceeding 400 kilometers per hour. Everything caught within the storm is carried around its enormous circulation. Unlike hurricanes on Earth, the Great Red Spot has no oceans beneath it. There is no land to weaken its strength. Nothing interrupts its endless motion. It simply continues. Year after year. Century after century. Although the storm remains enormous, careful observations reveal that it has been shrinking. It is significantly smaller than it was when astronomers first began studying it. No one knows how much longer it will survive. One day, this legendary storm may finally fade away. For now, however, it remains Jupiter's most recognizable feature. As you continue your journey above the cloud tops, countless smaller storms come into view. White storms, brown storms, oval-shaped vortices. Some last only a few weeks. Others continue for decades. The atmosphere is constantly changing. Clouds rise from deeper layers. Others sink back into the darkness below. Nothing remains still. Above the clouds, sunlight reflects from tiny crystals of ammonia ice. Far below, temperatures and pressures increase rapidly. The atmosphere grows thicker with every kilometer. Eventually, there is no clear boundary between sky and planet. The gas simply becomes denser, warmer, and heavier. Jupiter has no true surface. Only an endless transition from thin clouds to crushing depths. Deep below those visible clouds lies a world no human eye has ever seen. A place where pressure becomes so immense that hydrogen transforms into a strange metallic liquid. Electric currents flowing through that layer generate Jupiter's enormous magnetic field. It is the strongest planetary magnetic field in the solar system. Millions of kilometers away from the planet, its invisible influence is still present. Space around Jupiter is anything but empty. It is filled with powerful radiation trapped inside this gigantic magnetic bubble. Any unprotected spacecraft passing through it must endure one of the harshest environments found anywhere around the Sun. Yet even this invisible force creates something beautiful. Near Jupiter's poles, brilliant auroras dance through the upper atmosphere. They shine far brighter than Earth's northern lights. Some are hundreds of times more energetic. They never truly disappear. As long as Jupiter continues spinning, those glowing curtains of light continue their silent dance above the giant planet. Leaving Jupiter behind, your attention is drawn toward a smaller world. A pale sphere quietly reflecting sunlight. At first glance, it seems calm, almost featureless. Its surface is bright, smooth, and covered almost entirely by ice. This is Europa, one of Jupiter's four largest moons. Although it is slightly smaller than Earth's moon, Europa has become one of the most fascinating places in the entire solar system. As you move closer, long dark fractures begin to appear across the frozen surface. They stretch for thousands of kilometers, crossing one another like an enormous web. Unlike most rocky worlds, Europa has remarkably few impact craters. Its icy shell is constantly reshaped. Old scars slowly disappear. New ice replaces the old. The surface is far younger than many scientists once expected. Beneath that frozen shell lies Europa's greatest mystery. Almost every observation points toward the same remarkable possibility. Hidden below the ice is a global ocean. Not a small sea. Not scattered lakes. An ocean that may contain more liquid water than all of Earth's oceans combined. The water remains liquid because of Jupiter's immense gravity. As Europa orbits the giant planet, powerful tidal forces gently stretch and compress the moon. That constant flexing produces heat deep inside its interior. Enough heat to prevent the hidden ocean from freezing solid. Far below the surface, darkness fills every corner of this ancient sea. No sunlight has ever reached those waters. Yet on Earth, life has been discovered around deep hydrothermal vents where sunlight never exists. That discovery transformed the way scientists think about Europa. If life can survive in complete darkness here on Earth, perhaps similar environments could exist beneath Europa's frozen shell. No evidence of life has been found. Not yet. But Europa remains one of the most promising places to search. Future missions will study this mysterious moon in far greater detail. They will map its icy surface, measure the thickness of its shell, and search for clues hidden beneath the frozen landscape. For now, Europa keeps its greatest secret safely locked beneath kilometers of ancient ice. A silent ocean, waiting in the darkness. Your journey continues farther from Jupiter. Ahead, another enormous moon slowly comes into view. At first, it appears quiet, cold, almost motionless. But this is no ordinary moon. This is Ganymede, the largest moon in the entire solar system. It is even larger than the planet Mercury. If it orbited the Sun instead of Jupiter, it might easily be mistaken for a planet. Its surface tells the story of an ancient world. Dark, heavily cratered regions preserve scars from the distant past. Brighter terrain cuts across them in long ridges and grooves. These frozen landscapes formed billions of years ago and have remained almost unchanged ever since. Yet beneath that silent exterior, Ganymede is far more active than it first appears. Scientists believe another hidden ocean lies deep below its icy crust. Separated into several layers by high-pressure ice, this underground ocean may contain an astonishing amount of liquid water. Even more remarkable, Ganymede is the only moon in the solar system known to possess its own magnetic field. Invisible lines of magnetic force surround the moon, creating a miniature magnetosphere inside Jupiter's far larger one. It is a rare phenomenon. No other moon has been observed doing the same. Auroras shimmer above Ganymede's poles, By studying the subtle movement of these glowing lights, scientists discovered evidence suggesting that a vast ocean lies hidden beneath the surface. The magnetic field behaves differently because something conductive exists below the ice. The most likely explanation is salt water. Although the environment remains extremely cold, tidal forces and heat trapped deep inside the Moon may help keep parts of that hidden ocean from freezing completely. No spacecraft has ever explored those waters. No probe has drilled through the ice. Everything beneath the surface remains hidden from view. For now, Ganymede keeps its secrets beneath kilometers of frozen crust. It is a world of silence, a world of ice, and perhaps, somewhere far below, a world where liquid water has existed for billions of years. Leaving the frozen silence of Ganymede behind, another moon comes into view. Its colors immediately stand out. Shades of yellow, orange, red, black. No other moon in the solar system looks quite like this. This is Io, the innermost of Jupiter's four largest moons. It is also the most volcanically active world ever discovered. From a distance, the surface appears scarred and constantly changing. As you move closer, towering volcanic plumes rise above the horizon. Some reach hundreds of kilometers into space before falling back to the surface. Fresh lava spreads across the landscape. New eruptions reshape the Moon again and again. Unlike Earth, where volcanic activity is limited to certain regions, nearly the entire surface of Io is influenced by powerful internal forces. The source of that energy is Jupiter itself. Its enormous gravity continuously pulls on Io. At the same time, Europa and Ganymede add their own gravitational influence. The Moon is gently stretched and squeezed during every orbit. This endless flexing creates tremendous heat deep inside its interior. That heat has nowhere to escape except through volcanoes. More than 400 active volcanoes have been identified across Io's surface. Many remain active today. Some release lava. Others eject sulfur and sulfur dioxide high above the Moon. As these materials cool, they fall back onto the surface like colorful frost. That is why Io displays such unusual shades of yellow, orange, red, white, and black. The landscape is constantly renewed. Ancient impact craters rarely survive. Fresh volcanic deposits quickly erase the scars left by incoming objects. Few places in the solar system are as dynamic as this. Standing here would be impossible. The ground beneath you would never truly be still. Explosive eruptions. Rivers of molten rock. Toxic gases. Extreme temperatures. Io is often described as the closest thing to a living volcano on a planetary scale. It is beautiful from afar, but unimaginably hostile up close. As your journey continues, the glow of erupting volcanoes slowly fades behind you. The most violent moon in the solar system disappears into Jupiter's shadow. Ahead, one final Galilean moon waits in silence. Callisto. Far beyond Io, the scenery begins to change once again. The fiery glow of volcanoes disappears. The constant motion fades into silence. Ahead lies the outermost of Jupiter's four great moons, Callisto. From a distance, it appears ancient. Its surface is dark, quiet, and untouched by time. As you approach, countless impact craters become visible. Large ones, small ones. Some overlap one another after billions of years of collisions. No other large world in the solar system preserves such an ancient record of impacts. Unlike Europa or Io, Callisto shows very little geological activity. Its surface has remained largely unchanged for nearly 4 billion years. Every crater tells the story of an object that once crossed its path. Together, they preserve a history stretching back to the earliest days of the solar system. Beneath the icy crust, scientists believe another hidden ocean may exist. Although it is buried deep below layers of ice and rock, measurements suggest that liquid water could still survive there. Unlike Europa, however, Callisto experiences much weaker tidal forces. Its interior appears colder, more stable, and far less active. That peaceful nature has made Callisto especially interesting for future human exploration. Compared with the intense radiation surrounding Europa and Io, the environment around Callisto is significantly safer. Some scientists have even suggested that one day it could serve as a staging point for missions exploring the Jovian system. For now, those ideas remain part of the future. No human has ever visited this distant world. Only robotic spacecraft have passed silently overhead, capturing images of its ancient landscape. As you drift above its frozen plains, everything feels still. No towering volcanic plumes. No giant storms. Only the quiet memory of billions of years preserved across its surface. Your journey through Jupiter's remarkable family of moons is almost complete. Behind you lies the largest planet in the solar system. A world of endless storms, powerful magnetic fields, hidden oceans, and extraordinary moons. Each one is unique. Each one reveals a different chapter in the story of our solar system. As Jupiter slowly fades into the darkness behind you, your journey continues toward the even more distant worlds waiting beyond. You leave the giant worlds behind and continue drifting through the quiet darkness of space. The planets grow smaller with every passing moment. The sun becomes a distant source of light. Ahead, countless rocky bodies silently follow their ancient paths around the solar system. Most of them will never become planets. They have traveled through space for billions of years, almost unchanged since the birth of our solar system. These are the asteroids. Ancient fragments left behind after the planets formed. Each one is a small piece of history. Some are no larger than a house. Others stretch for hundreds of kilometers. Most orbit peacefully between Mars and Jupiter inside a vast region known as the Asteroid Belt. Although millions of asteroids occupy this part of the solar system, the space between them is enormous. Contrary to what many imagine, spacecraft can pass through the asteroid belt without constantly dodging giant rocks. Collisions are extremely rare. Yet every asteroid carries the memory of a much younger solar system. They formed more than 4.5 billion years ago from the same cloud of gas and dust that created the Sun and the planets. Many never merged into larger worlds because Jupiter's immense gravity constantly disturbed their orbits. Instead of becoming another planet, they remained scattered across space, frozen in time. As you drift among them, each asteroid appears different. Some are smooth, others are jagged and irregular. Many slowly rotate as they orbit the Sun. Some travel alone. Others belong to families created long ago when larger asteroids shattered after violent collisions. These silent worlds may seem lifeless, yet they contain valuable clues about the earliest history of our solar system. Their rocks preserve minerals that formed before Earth itself existed. By studying them, scientists can look billions of years into the past. Every asteroid is like a time capsule, waiting patiently to tell the story of how our cosmic neighborhood first came into existence. As your journey continues deeper into the asteroid belt, another question begins to emerge. What happens when one of these ancient travelers leaves its quiet orbit and heads toward a planet? Although most asteroids remain safely within their stable orbits, not all of them stay there forever. Over millions of years, gravity slowly changes their paths. The powerful influence of Jupiter, the gentle pull of Mars, even close encounters with other asteroids. Together, these forces can gradually alter an orbit. Some asteroids begin drifting away from the main belt. A few eventually cross the paths of the inner planets. These objects are known as near-Earth asteroids. Despite their name, most never come close enough to threaten our planet. Space is unimaginably vast. Even what astronomers describe as a close approach often means millions of kilometers away. From time to time, dramatic headlines appear claiming that a giant asteroid is about to destroy Earth. Stories spread rapidly across the internet. Predictions become exaggerated. Fear replaces facts. In reality, every newly discovered asteroid is carefully tracked by astronomers around the world. Its orbit is calculated again and again using precise observations. If there were a genuine danger, scientists would know long before the object arrived. One well-known example was asteroid 1998 OR2. Because of its size, it attracted worldwide attention. Some online posts claimed it would strike Earth. Those claims were false. The asteroid passed safely millions of kilometers away. Events like this remind us how important careful observation has become. Modern telescopes scan the sky every clear night. Automated surveys discover thousands of new asteroids every year. Each discovery improves our understanding of the solar system. And each new orbit helps scientists predict where these ancient travelers will be many years into the future. Even so, impacts are part of Earth's history. Small objects enter our atmosphere every single day. Most are no larger than grains of sand. They burn up high above the surface, creating brief streaks of light. The shooting stars we admire on quiet nights are usually nothing more than tiny fragments of cosmic dust meeting Earth's atmosphere. Beautiful, brief, and completely harmless. Larger objects are far less common. But when they do arrive, they remind us that our planet is still part of an active and ever-changing solar system. When a rocky object enters Earth's atmosphere, its journey changes completely. Until that moment, it is known as a meteoroid. It may have traveled through space for millions, or even billions, of years. But the instant it encounters our atmosphere, everything happens with incredible speed. The object rushes toward Earth at velocities ranging from about 11 to more than 70 kilometers per second. Air cannot move out of its way fast enough. Instead, it becomes intensely compressed. That compressed air heats to extraordinary temperatures. The rock itself begins to glow. A brilliant streak of light races across the sky. This is what we call a meteor. Many people simply know it as a shooting star. Despite the name, it has nothing to do with stars. It is only a tiny fragment of rock burning high above our planet. Most meteors are surprisingly small. Many are no larger than grains of sand. Others are about the size of small pebbles. Almost all of them completely disintegrate before reaching the ground. Every day, Earth's atmosphere protects us from countless tiny visitors arriving from space. Occasionally, however, a much larger object survives the fiery descent. If part of it reaches the surface, it is no longer called a meteor. It becomes a meteorite. These rare survivors provide scientists with remarkable opportunities. Many meteorites are older than Earth itself. Their minerals formed before our planet even existed. By studying them in laboratories, researchers learn about the earliest days of the solar system. Some meteorites are rich in stone. Others contain large amounts of iron and nickel. A few are mixtures of both. Each type preserves a different chapter of cosmic history. The largest meteorites found on Earth weigh dozens of tons. They remind us that some objects are strong enough to survive an incredible journey through the atmosphere. Fortunately, truly dangerous impacts are extremely uncommon. Earth's atmosphere burns away the overwhelming majority of incoming objects long before they reach the surface. For billions of years, this invisible shield has quietly protected life below. Yet our planet still carries reminders of the few visitors that were large enough to leave their mark. Some of those scars remain visible even today. The surface of Earth preserves remarkable evidence of ancient impacts. Some scars have been erased by wind, rain, and shifting continents. Others remain visible after millions of years. They remind us that our planet has never been isolated from the rest of the solar system. One of the most famous impact sites lies beneath the Yucatan Peninsula in Mexico. Today, much of the crater is hidden beneath layers of rock and sediment. Yet its enormous size reveals the scale of the event that created it. Around 66 million years ago, an asteroid roughly 10 kilometers wide struck Earth at tremendous speed. The impact released more energy than billions of nuclear explosions. A powerful shockwave spread across the planet. Wildfires ignited over vast regions. Dust and vapor rose high into the atmosphere. For a long time, sunlight struggled to reach Earth's surface. Temperatures dropped. Food chains collapsed. Approximately 75% of all species disappeared. Among them were the non-avian dinosaurs that had ruled the planet for more than 160 million years. Yet life endured. The survivors slowly adapted to a transformed world. Over millions of years, new ecosystems emerged. Eventually, mammals became the dominant large animals on Earth. Without that ancient impact, the history of life might have followed a completely different path. Not every crater on Earth is so dramatic. Across the planet, scientists have identified hundreds of confirmed impact structures. Each one tells the story of a different collision. Some were created by relatively small objects. Others resulted from far larger impacts. Together, they reveal that asteroid collisions have shaped Earth's history many times. Fortunately, events on the scale of the dinosaur extinction are extraordinarily rare. They occur over immense spans of geological time. Modern astronomy now allows scientists to detect and track many potentially hazardous asteroids long before they approach our planet. Around the world, observatories continue watching the skies every night. Their work helps ensure that humanity will never again be surprised by a visitor of truly catastrophic size. The universe remains dynamic, but our understanding of it grows stronger with every observation. Not every asteroid follows the same path around the Sun. Beyond the main asteroid belt, several unique groups travel through the solar system in very different ways. One remarkable example is the Trojan asteroids. These ancient worlds share Jupiter's orbit around the Sun. Instead of following directly behind or ahead of the giant planet, they gather around two special regions located approximately 60 degrees in front of and behind Jupiter. These locations are known as Lagrange points. Here, the combined gravity of the Sun and Jupiter creates areas of long-term stability. Asteroids caught within these regions can remain there for millions, and sometimes even billions, of years. Thousands of Trojan asteroids have already been discovered. Many are believed to be remnants from the earliest days of the solar system. They preserve valuable clues about how the giant planets formed and migrated through space. Far beyond Jupiter, countless other small worlds continue their silent journeys. Some orbit beyond Neptune inside the distant Kuiper belt. Others travel from the far reaches of the Oort cloud, returning only after millions of years before disappearing once again into deep space. Together, these distant objects remind us that the solar system extends far beyond the familiar planets. The space between the worlds is filled with ancient travelers. Some are only a few meters across. Others rival small moons in size. Each follows its own orbit. Each tells a different story. Among them is Ceres, the largest object within the asteroid belt. With a diameter of about 940 kilometers, Ceres contains nearly one-third of the entire belt's mass. Unlike most asteroids, it is large enough for gravity to pull it into an almost spherical shape. For that reason, astronomers now classify it as a dwarf planet. Spacecraft have revealed bright deposits scattered across its surface. Evidence suggests that salty water once reached the surface from below. Perhaps, deep underground, small reservoirs of briny liquid still exist today. Even within the asteroid belt, surprises continue to emerge. Worlds once thought to be nothing more than lifeless rocks now reveal signs of complex geological histories. Every new mission reminds us that even the smallest worlds can hold extraordinary secrets. Your journey through the asteroid belt is slowly coming to an end. The countless rocky worlds begin to fade into the distance. One by one, they disappear into the darkness. Yet their story continues. Every asteroid you have passed is a survivor from the earliest days of the solar system. They are older than mountains, older than oceans, older than life itself. They have remained in space for more than 4.5 billion years. Quietly orbiting the Sun while planets formed, continents shifted, and civilizations rose and fell. Although they often appear lifeless, asteroids have become some of the most valuable scientific targets in modern astronomy. Space missions have landed on them, collected samples from their surfaces, and returned those ancient fragments to Earth. Inside those tiny pieces of rock, scientists search for answers to some of the oldest questions ever asked. How did the solar system begin? How were the planets assembled? What ingredients were present before Earth became a living world? Each sample brings us a little closer to understanding our own origins. Perhaps the greatest lesson these silent travelers offer is that even the smallest objects can preserve the largest stories. A single fragment of stone can reveal events that happened billions of years before the first human ever looked toward the sky. As you leave the asteroid belt behind, the darkness ahead grows even deeper. Beyond these ancient rocks lie frozen dwarf planets, distant comets, and the mysterious frontier at the edge of the solar system. Our journey is far from over. The universe still holds countless worlds waiting to be explored. Each one carries another chapter in the endless story of the cosmos. And together, they remind us that every discovery begins with a single question. One that has inspired humanity since the very first night we looked up at the stars.